Hey everyone, sorry I'm not there today. Your lesson today is on quadrilaterals, right? That's our quadrilateral unit, and we're starting with parallelograms, which was one of the easiest ones. This unit ties into the unit of angle measurements of polygons. Okay, I believe that's section 3 in algebra um, where we talked about interior and exterior angles of polygons, and try to keep in mind that unit that you already learned, and specifically interior and exterior angles of quadrilaterals, right? We know that they equal 360. Okay, so a quadrilateral is, well, a polygon is a quadrilateral in which both pairs of opposite sides are parallel. So let's go ahead and define that. To both pairs of opposite sides are parallel. Okay, so we have some properties of parallelograms that are going to make your life a lot easier. All right, and one of the hard parts about this unit is just trying to remember which properties go with which shape. Okay, but it's not necessarily that hard. So the first one that you need to know is that opposite sides are congruent. Okay, that's pretty self-explanatory. It even looks like it in the picture, right? If the AB and DC are parallel, they're also congruent. Opposite sides are congruent. Okay, and then not only that, but opposite angles are congruent. Angles are congruent. So looking at number one, angle A is opposite to angle C, right? And those angles are going to have the same measure. Okay, property number 3, we have consecutive angles are supplementary. All right, and you guys know supplementary means equals 180. And so that means if I'm looking at picture number 1, angle A and, well, consecutive, guys, means like one after the next. So angle A and angle B are supplementary, means you would add them up and they would equal 180. Okay, and then finally, you see this with number 3 and 4. That is that diagonals of parallelograms bisect each other. Okay, so if we're looking at picture number 3, we have the diagonal from angle S to angle U is being, it is bisecting RT, so it's cutting RT in half. All right, and then RT is bisecting SU, so RT is cutting SU in half. All right, and we're going to use this to solve some of the problems. Okay, so let's do number 1. Number 1 says, each quadrilateral is a parallelogram. Find the missing measures. All right, so AD is congruent to BC, right? So AD is 8. DC is 15. The measure of angle A, we know that A and C are the same, right? The opposite angles are congruent. And then we also know that consecutive angles are supplementary. So A plus the measure of angle D equals 180. So let's just do 180 minus 68. So angle A is 112. That means C is 112. And then the measure of angle B is going to be the same as the measure of angle D, right? These are also the same. So B is 68. Whoa. Sorry, guys. B is 68. Okay, so let's try number 3. So this is using the fourth property of parallelograms, that diagonals bisect each other. I know that RT is 30. So that means that if it's cutting it in half, RV and VT are both 15. I'll go ahead and draw that in. So let's see what we can do with this. UT is going to be the same as RS, right? So I'll go ahead and mark that. So UT is 27. ST is the same as RU, so ST is 18. All right, and VS is the same as UV, which is 7. Okay, and then I have VT, which we already talked about, is 15. Okay, I'll do number 6 and leave you guys number 5. Okay, so number 6 says given angle GHF. GHF is this one up here is 34. And HJF, okay, they give us the large angle here is 124. And 34. And FKJ is 79. This is 79. Let's try to find everything else. Okay, so, well, what do we know about parallelograms? So specifically this, a quadrilateral. Ooh, that's not what I meant to do. Sorry, guys. Draw. Quadrilateral with both pairs of opposite sides are parallel. Okay, so this should, specifically this word should bring up something, right? Parallel lines give you angle relationships, right? So if we have parallel lines, we're going to have alternate interior angles. Okay, so if GHF is 34, what else is 34? This one right here, right? Because these two angles are parallel. Or sorry, those two sides are parallel. Okay, so let's just go ahead and solve this one at a time. GFJ. GFJ. All right. How about FGH? FGH. Okay, that one is the same as this one, right? So it's that one is 124. That one was given. Okay, HFJ. We figured out was 34 because it's alternate interior to the GHF that was given. Okay, how about HJK? HJK. All right, we don't know anything about that one yet. But I guess we could start solving. So let's start with, I'll go change my color so you guys can see. This one down here, right? If we know two sides of a triangle, we can figure out our third, right? I'm going to add 79 and 34 and subtract it from 180. So 79 plus 34 and subtract it from 180. So it's 67. So this yellow one here is 67. That makes this one up here, the alternate interior one, also 67. Okay, and then of course we have our vertical angles. This is also 79. Okay, and then we know that these two angles, 79 and where the K is, are supplementary. So we can go ahead and do 180 minus 79 to find where this angle K is 101. And it's a vertical angle. Okay. All right, so let's go ahead and start figuring out some of these angles so we can solve the problems. So GFJ, all right, it looks like we're going to have to find the other side of 67, right? Which we can do because they gave us that the angle J is 124. So that means G is 124. So I'll do 124 minus 67. Okay, so this angle right here, which is red, oh, I forgot what it was already, is 57. Okay, so 57 is right here. Okay, so now we have two angles of a triangle. I can figure out this other angle, 101 plus 57, subtracted from 180. Nope, I did it wrong. Plus 57, subtracted from 180, is 22. Okay. So this one right here is 22. And then I figured out that that red angle was, I can't even remember. It was 34. So if this red angle is 34 and this one is 22, I can put them together. 34 plus 22. So you get 56. Okay, so GFJ is 56. So that's 56. All right, HGK, HKJ, HK and J, we figured out was 101. JGH, JGH is 67. So it's a good thing I drew all over my pictures. FJGJ, FGJ is 57. FHJ. Okay, well, we have that being alternate interior to 22. So this one's 22. And GJF is 67. Okay, so that wasn't really so bad. So you guys are going to do number 5. I'm going to do number 10 and leave you number 9 Okay, so let's go ahead and try to figure this out. It says if ns is 2x plus 7, 2x plus 7, sq is 5x minus 23, find nq. All right, well, this should be pretty easy because we know from the property above, property number 4, diagonals bisect each other. So ns and sq are congruent. So I'll say that 2x plus 7 equals 5x minus 23. I'll subtract 2x on both sides and add 23 to both sides and get x equals 10. So if I plug it in, right, I can plug it into this side, it would be 27. So this is 27 plus 27, which I believe is 54. So NQ equals 54. All right, number 11. Find the measure of angle B. Okay, so looking over at our properties of parallelograms, property number 1 says, or 2 says opposite angles are congruent. So A and C have the same measure. So I set them equal to each other. 6x minus 15 equals 4x plus 11. Subtract 4x on both sides. Add 15 to both sides. What is that? 26. Sorry, guys, my brain's working slow. Okay, and x equals 13. All right, so I'll plug in 13 to 4x plus 11. 4 times 13 plus 11 to get 63. Okay, so these angles, A and C, are both 63. Okay, and then we also know that with property number 3, consecutive angles are supplementary. So consecutive means one after the next. So B plus C equals 180. So what would angle B be? So I will say 180 minus 63 is 117. So angle B equals 117 degrees. Okay, I'll try number 14. I'll leave you guys 13. So number 14 says ABC equals 115. So that's the large one. Angle B is 115. Find ADB. That's this one right here where the arrow is pointing. Okay. All right, well, I know that this ADB, this angle right here that I just drew in, is alternate interior to DBC, right? So those two angles are the same. So I'm going to say that 6x minus 11 and 4x plus 6 equals 115, right? Because we know that ABC is 115, and then we know that this angle here is 4x minus 6, so we can add them together and set them equal to 115. All right, so let's combine like terms. That's 10x minus 5 equals 115. Okay, I'll add 5 to both sides. That's 10x equals 120. And divide by 10, I get x equals 12. Okay, so what am I trying to find? Angle ADB. So I will do 6 times 12 minus 11 to find this angle here is what they're asking for. 6 times 12 minus 11. is 61. So the measure of ADB, angle ADB, is 61 degrees. Okay, and then just because it's good for you, I put the beat the test questions in your notes. So let's talk about them together. Number 1, if two opposite angles of a quadrilateral are supplementary, is a quadrilateral a parallelogram? All right, well, we got to think back to definitions of parallelograms, right? We know that opposite sides are congruent, opposite angles are congruent. Okay, but if I say a quadrilateral, both pairs of opposite sides are parallel, right? A parallelogram could look something like this, or something like this, a rectangle, or even a square, or maybe even a rhombus. It's like a crooked square, right? So we have all these different types of parallelograms. So opposite angles of a quadrilateral are supplementary. That means equals 180. Is a quadrilateral a parallelogram? Well, it could be. So it says no, because in parallelograms, angles are supplementary if and only if they're consecutive. Well, in this quadrilateral, or in this parallelogram, that's true, right? But what about the rectangles and the squares? So what if it's 90 and 90, it equals 180, right? Charlie, get out of here. I know, it's okay. Okay, so I'm going to say no, that's not true, because there are cases that make it true. B says no, because opposite angles in a parallelogram are never congruent. Opposite angles are always congruent, right? These are always congruent for parallelograms. Okay, so this one's definitely not true. Okay, C says yes, but only when the angles of a quadrilateral are right angles. Okay, that sounds good so far. Otherwise, it would be a trapezoid rather than a parallelogram. Otherwise, Charlie, it's okay. Otherwise, it will be a trapezoid rather than a parallelogram. Yep, that's also true. Okay. So, yes, because only squares have that property. Well, squares do have that property, but not only squares have that property. Rectangles also have that property. And squares are both parallelograms and quadrilaterals. So I think C is your best choice here. Okay, so let's do number 2. Number 2 says, the deck that Kenneth is building is in the shape of a parallelogram, ABCD. The measure of angle C is 1/3 the measure of angle B. Find the measure of each angle of the deck. Okay, so I'm going to draw a picture. All right, so that's not a very good picture. I have my pairs of parallel sides. I know that C is 1/3 of B, so that means that A and C are 1/3 of B and D. Okay, so let's go ahead and say that angle B is X, and angle C is 1/3 of B, so 1/3 of X. All right, I'll plug that into my picture. So B is X, and C is 1/3 of X. Okay, and coming back to my properties of parallelograms, that would be consecutive angles are supplementary, and B and C are consecutive. So I can say X plus 1/3 of X equals 180. All right, so 1x plus 1/3 x equals 180. I know that if I'm adding fractions, I need like denominators. So 3/3 x plus 1/3 x is 4/3 x equals 180. And then to eliminate a fraction, I have to multiply by the reciprocal on both sides. So I'm going to multiply by 3/4 to both sides and get x equals 180 times 3 divided by 4. So let's do that. 180 times 3 divided by 4 is 15. Okay. That seems small. That doesn't seem right. Oh, because I put divided by twice. Let's see. Let's try this again. 180 times 3 divided by 4. 135. 135. I'll just add in my 3 there. Okay. Sorry about that, guys. So if x is 135, that sounds a little bit better. So angle B is 135, and B and D are congruent, so D is 135. And then 1/3 of 135 will give me C and A. So I'm just going to divide 135 by 3. So angle A and angle C are both 45. All right, and we're done. I'm going to make another video later. I hope you guys have a good day. Bye.